The desk of Ladyada welcomes you.
Hola, welcome to this world of Circuit Playgrounds. Tonight we're doing some fun video stuff and we're going to play with MicroPython on Circuit Playground. So that's a new thing, I get confused. CircuitPython is our variant of MicroPython on the Circuit Playground board. So actually it's running some Python code right now, but I would like to play with it a little bit more, maybe show it off so people can see the excitement that is occurring.
The world is a playground.
Yeah. Anyways, so over at my computer right now, I'm just doing a little bit of editing. I put in that PDM microphone. I'm going to get back to the digital signal processing stuff, but I'm pretty sure I'll be able to get it working. So I just sort of started routing that in. And with the space I have left over, I put in some interesting stuff that I'll chat about later. And I'm also rotating the accelerometer. So I have to finish routing a couple wires here and routing a couple wires there. But for the most part, I'm not too concerned. I think I can fit all this new stuff, and this will be Rev E. I'll get back to that later. And what I'm working on today is, like I said, just trying out CircuitPython. Scott, who has been builds nonstop. Scott, the build maker.
Scott's in the chat. Everyone say, "Hey, Scott."
Hey, Scott.
You're doing a really good job.
Good job.
Seriously.
Yeah. So let me make a backup of this this code that I wrote, and then I can talk about what I wrote.
I have one announcement.
Yeah, we'll go.
The person who won one of the boards, Stuff with Kirby, got his board.
Great.
Stuff with Kirby has already done some CircuitPython and Circuit Playground. Stuff with Kirby is in the chat. Stuff with Kirby.
Ask Scott for the latest firmware build because you can follow along. We fixed some bugs and more things.
Okay.
So what's neat about CircuitPython, and let me go over to my drive, is when I plug this board in. Oh, hey, can you go to the overhead really fast? This board, yeah. So this board right here, when I plug that into USB, this is a little USB port up here. When I plug that into USB, it shows up as a disk drive, and called CircuitPy. And if you get like properties about it, it's 2 megabytes. That's the flash chip right here. There's a little flash chip that will show up as a disk drive, and so you can store up to 2 megabytes of files, code, images, like WAV files, whatever you want. So that's kind of handy. And you can write code. I'm using the Mu editor, which is really nice because it has a REPL. So the device is both a mass storage device and a serial port device. I'll put my drink behind the Circuit Playground there. So when you open up Mu, you can get a REPL down here, and you can write your code up here. So this is kind of nice. It's a very handy way to write code because you get this interactive element here, as well as if you want to write Python code. So this is like a Python interpreter here, and it's like a real Python interpreter. It runs Python. You can do Python things with it. You can import math. You can do math dot log 2.17. You can math square root of 2. You can do all sorts of stuff in here. And part of what CircuitPython adds is we have an API for dealing with hardware that makes it easier for beginners. We'll be doing even more work with it to make it simpler, but we wanted to make it as easy as possible for beginners to get started. So let's start with just the most basic stuff. I'll just delete all of this code. Hold on. Because I have a backup of it. And I'll even delete all the NeoPixel stuff. So, for example, let's say you want to have an analog input. So, for example, you can have the microphone, and this is a named pin. It's a pin called microphone, and that's connected to the microphone. You say, I want this to be a sound analog in, and then you can have something like while true, print, and then sound.value.
I like how it guesses what you want to do.
Yeah, it has a little bit of like an auto completion thing. It doesn't know about CircuitPython.
But it's trying.
It does the Python stuff.
It's like a helper.
So actually, let me try running this. So when I save this file, and then because I did stuff in the REPL, I have to hit Control D. This actually prints out the raw values from the microphone, and when I tap the microphone, the values they do increase. Oh, hold on, I have to get out of the way. Although it's a little hard to see. Maybe if I go here, can you see the values?
Yes, I can see the values.
Okay, thanks. It's a little tough to well, actually, one thing we can do is make it a little easier to see what's actually happening, because these values are going by really, really fast. So the average value is like 24300 or something. So I can create, this value, and then I can say, I just want to get basically remove the DC offset. So let me save that. And then now you'll see the values are at least, hold on, let me move this up to the right. The values are at least smaller. And you can actually tell when I speak, the values get a little bit, I get 3-digit values. But I want to make this a little bit easier to read. So first up, let's, do I have math absolute? Do I have absolute? No, I don't think.
Can you move the CircuitPlayground board like 1 to 2 millimeters down?
Oh, sorry.
Just get in that circle.
Yeah,
okay.
yeah.
Thank you.
Sorry, I'm looking to see if I have the. This is a challenge. I have to move my books out of the way. Hold on. I don't have an absolute value. I don't know. I guess I can. I guess I'll do it by hand. I'll say, volume equals sound.value minus average sound, and then if volume is smaller than 0, volume multiply it by -1.
I checked in the chat. Maybe Ladyada can also confirm this.
Yeah.
I think the latest version of Mood does include our boards, right? They did a pull request?
It does. This
Okay.
automatically detects the VID and PID and will automatically come up with a REPL. Okay, so let me reboot it. Okay, so that worked. So I basically got rid of the negative value. And now, okay, it's a little bit better, but it's still a little challenging because it's just happening so fast. So one thing I can do is put in a delay, but the problem is if I put in a delay, it might not catch spikes. So what I'll do is I'll actually do a little trick where I'll print number of stars instead of a value. So instead of just printing the volume, I'll do, for x in range volume, and then divided by 5 maybe. We can tweak that number. Print star, and then is it comma afterwards? No, that's not it. It's maybe, how do you, hold on. And equals, I'll try this. Okay, and then print. Oh, sorry. Indent properly. Right. Okay, so now when I speak...
Oh, Scott's saying print, parentheses.
I can do this times...
Yeah, here, I'm gonna hand you this last
I'm not a big Python. It's you can multiply strings, right?
This is what he's doing. This says that.
Oh, yeah, you can multiply strings. Python. Actually, I'll time volume. Okay, well, there's so many ways to do it. That's the motto of Python, right? It's not.
The internet brings us together to code together.
Yeah, I have to learn this too. So
Thanks,
this and then divide by 5. Great. So I didn't have to even stir int. Maybe I have to put parentheses around this. Yeah. Okay. All right. So now when I'm speaking, you want to do like audio stuff. You can see the audio on the. You can see the little stars are printed. So the louder I am, the more stars I get. Yay! Say something loud.
Loud.
Thank you. So that's like a really quick way of playing around with the MicroPython and Python. And then, you know, of course, if you want, you can have the LEDs do something as well. So the example code I had before did something kind of similar. Okay, so you've got the volume. Actually, I ended up trying a couple different things like sampling. But for this, I did actually have to loop over it. So I imported NeoPixel. And then let me grab my code that I used. And then I created a NeoPixel object with 10 NeoPixels on the NeoPixel pin. And then I can do for P in range 10. This you kind of have to do. You have to iterate. If volume divided by 20 is larger than P, set the pixel and then the pixel string, that pixel number. I'll make this a little easier to read. So the pixel number in range equals, and then I'll just make it, you know, red. Else, I'll make the pixel off. And then you just have to write it. Let's see if this works. So now we've got a sound-reactive NeoPixel ring. So as I speak, not only am I going to get, it's a little slower, right? Because right now it's writing those NeoPixel values all the time as well, but it's still picking up the audio peaks. You know, another thing you can do is you can sample a bunch of, you can get a bunch of readings and then do it, but this works, you know, pretty good. So with Python, you're not going to get the performance you get with C or C++. You know, with Arduino, of course, you can do things so fast. With Python, it's not as fast, but you can see the development time is very easy. So there's no compilation and there's no upload. As I'm typing code, like if I'm like, you know what, I want to make these LEDs brighter, I change this to 20, and then I save it, and 2 seconds later, it starts interpreting the new code and it's brighter. Or maybe, you know what, I'm like, you know what, I like this, but I actually want it to be like purple. You can very quickly change the code, like instantly. Like within 2 seconds, you write the code, you save it, and your new code is running. So it's a different way of approaching programming. Again, you're not going to get that high efficiency code. You know, I'm not going to write FFT in Python and have it run in real time. You can write a C helper that, you know, will work with MicroPython behind the scenes to do it, like we do with the NeoPixel. There's a helper to twiddle the pin fast enough. But for a lot of beginners, like this is kind of as complicated as you want your project. You want a sound reactive project. You know, you want something where you touch a button or a capacitive touch thing, or it makes a beep. But you don't need to have function pointers. You don't need to have memory allocation. You want to just like get started immediately. So this is insanely fast. And I'll say another thing, if I was writing this in C code, even though I've been writing C code for over a decade, actually more than that, like almost 2 decades, I would still have constant mistakes and compilation errors, and it would be much harder for me to write it all out at once. With Python, you can see you do piecemeal, compile, see how it works. If you have any errors, you fix them very fast. So very quick turn prototyping. So it's even more prototyping than Arduino. So I can't wait till the people in AVR Freaks see this, because their heads are going to explode when they see how easy it is now to program a microcontroller.
So I'm writing an article about MicroPython and CircuitPython. And previously I wrote an article called Why Arduino Won and Why It's Here to Stay. So this is a continuation of that original article that I wrote maybe 6 years ago on MakeZine.com, which is also known as Make Magazine. It's a print publication and an online publication. And I can tell you that if you were to time the download to your microcontroller from the Arduino IDE every single time you're trying something new and add it all up, it eventually becomes hours, that becomes days, that becomes weeks. And one of the things that's a lot of fun, and one of the reasons why I've enjoyed returning to some microcontroller programming, is it's instant gratification. You're instantly changing things, you're instantly seeing the results, and you're instantly seeing something that came into your head, and if it works or not. And you don't have to sit there and wait for 30 seconds, for 45 seconds. So the rapid development
there's no, and another thing that's nice
is really nice.
Because it auto resets the core, the MicroPython core, the disk drive and the UART don't disappear. Notice that the UART is still running. Like, it never goes away. Nothing, the USB doesn't disappear and reappear. There's no bootloader, which I find really frustrating. Like, there's no risk here. Like, you actually never reach the bootloader with MicroPython or CircuitPython. You're always in the runtime because your code is interpreted within the runtime. So there's no like bootloaders, there's no like weird like, oh, like the UART disappears, the COM port dies. This UART string that you see right here, you know, it'll stop and start, but it doesn't ever disappear and come back. Like, you don't have any of that stuff. So it's very nice and fun to program. And it's like, again, it speeds everything up. And there's like, you know, even with Arduino, sometimes like your hub will like spaz out, or like the bootloader will crash, or the USB will crash. All that stuff is protected from you. Like, you don't really have the possibility of doing that. Like, don't worry, you can crash it. But it's not like with Arduino where it's like very easy to have a memory, like, you know, you have an array and you just write past the array and you just like blow away your code and like it just starts crashing crazily. That's not going to happen. You have a bigger sandbox here. So good for beginners. Good for people learning. And another nice thing is once you're done with the code, you know, it's like you can grab it off with a microcontroller when you're done. So like if you look at my CircuitPython, I have like a couple different test programs. So I just wrote this main.py, right? This is the program I was recently running. But I can close this and I can call this, you know, my sound program. And then, yeah, this is my, let me try my, now there's no main.py, so it's like I'm not doing anything. If I open test.py, can I save? No. I'll make a backup. I can copy this, call this, rename this to main.py, and I'll load main.py. So this is my big test program. So this program does a whole bunch of tests. It tells you the temperature, the light level, sound level. It does an I2C scan, and when you touch the capacitive pins, it lights the pins up. Although it doesn't like the right pins because the pin numbers changed, I think. Yeah, I have to fix that. But, so that's what I'm up to. So are there any questions? I'll really quickly.
No, people are in the chat and they're talking amongst themselves.
Okay, that's great. Well, that's my demo. I don't really, I mean, like, we'll do more.
Chicago Electronics Distributor says, very cool, great explanation of the merits of MicroPython. I agree.
Yay, thank you.
Scott's in the chat, and Scott was talking about some of the fun nuances of using CircuitPython.
Yeah.
And that's it for tonight, folks.
Yeah. Let me just get this demo working properly. Oh, wait, hold on. This was supposed to be 4, 5. This autocomplete's kind of cool, but it's also annoying. And then this is A11. Okay, so now the touch should work. Yeah, there you go. So now the touch lights up the matching pins. So this does capacitive touch testing, button pressing, so I can press the button and it's like, hey, press the button. And then if I flip the switch, it'll make a very annoying beep. Hold on.
It's my favorite song.
Yeah, I know. It's like we don't have the piezo on a helper yet, so we're actually like bit banging it, which is why it doesn't sound right. But that's a little demo. Just tests all the NeoPixels. It actually does all the hardware test, so that I could quickly make sure that the hardware is good. So when we make these prototypes, I quickly toss this program on, and I look at the output and I try all the capacitive touch buttons, and that's how I know it works.
So Kirby, who got a pre-release prototype for helping us out in chat, mentioned it's fun how you can use this on multiple computers because the code can be opened and viewed on other computers.
That's what I like too. So you have 2 megabytes. You can store a whole bunch of programs, and you can, of course, you should always back it up. But then if you're taking it to school or home or work, you don't have to like sync your files because your development environment actually lives on the board. You just need the editor, and you can actually use a text editor. You don't need to use Moo. Like I like Moo because it's a very nice little integrated editor. It's really fun to use, but you can use, I use Emacs and like Putty. You know, you can use Atom. You use VI. You can use whatever the hell you want. But your code goes with you, and then you can always save and back it up. So you like, instead of having a sketch folder, it's like on the device itself. It's kind of neat.
Yeah. And whatever weirdo like IDE you like Atom or whatever, you can use.
You can totally use it. It's just standard.
It's totally cool.
Text file, Python file, totally plain, and then UART output, also totally plain.
Okay.
That's my demo.
That's it for tonight, Ladyada.
Yeah. What's cool about doing these MicroPython demos is how fast they are.
They're very fast demos.
Very fast.
Okay, well, if you like what we're doing and you like Scott, buy something in the Adafruit store. Go to adafruit.com and pick up something. Support open source hardware companies.
It's a good idea.
That's a good idea. Okay. Well, that's tonight's show, everyone. Thank you for tuning in on the internet. This is Desk of Ladyada with Ladyada. And don't forget, once you let go of what you are, you might become what you might be. Ooh.
Kind of deep.
Yeah. Okay.
All right. Thanks for watching, everyone.
Say bye.
Bye.